theme is Cell Stoic. So today's lesson is going to take skills you already know, but put them together in a sequence that you haven't done before. You did stoichiometry in Chem 20. We're going to do some stoic today, but it's going to be with electrons. So we're going to need our table to look up the ratio of electrons in a half reaction to the metal that we're going to plate or form. Okay? Pretty much all of your questions will be the formation of metals. It doesn't have to be, but that's what most of them are. So if you looked at gold in your table, there are 3 electrons needed for 1 gold. Okay? That's what I mean by Chem 20 stoichiometry, using an equation or a half reaction to make some predictions. What's going to be new is getting to the moles of electrons. Current and time can be used to calculate how many moles of electrons. So we're going to do a little bit of physics. Okay? Now I'm going to make this a double arrow because we'll be able to work backwards. We'll be able to work in every direction. From moles of electrons, you can get to moles of whatever metal is being asked about. Okay? This is our stoic, where we need a half reaction. You don't ever use full nets. We always use halves because we need the ratio between electrons and what we've made. Redox reactions don't show electrons, they canceled out. You may be given a full on an exam, you want the half. Last step, which is really science 10, figure out the mass for moles. Okay? So that's been a couple years that you've been doing that. Okay? Moles is mass over molar mass if it's a pure substance, and everything we do will be pure. We won't have any solutions here. So you have 2 styles of questions. You could get current and time. Step 1 is moles of electrons. Step 2 is moles of electrons to maybe moles of silver. Step 3 would be mass of silver. Or backwards. I tell you there's 20 grams of silver made. You can tell me how many moles that is. You can tell me how many moles of electrons is needed, and then you could solve for one of those, current and time. You could not solve for both. Okay? And in bullets, we kind of have that typed out. So let's jump into how do you use current and time to get moles of electrons? So we're going to do this in 2 steps. We're going to talk about how much charge a power supply delivers first, and then we'll relate charge to how many electrons it actually is. Okay, so the total charge that a power supply delivers is measured in coulombs and given symbol big Q. So it's not that little q from thermodynamics. Okay. The current times the time will tell you how much charge you have. The current is measured often in amps, but the meaning of amps is coulombs that went by in 1 second, coulombs per second. The time must be in seconds. And rarely will you get a question in seconds. You should know how many seconds are in a minute, but I just want to give you a reminder of seconds in an hour. So 1 hour has 60 minutes, a minute has 60 seconds. So it ends up being 60 times 60. So 3,600 seconds in an hour, and we'll use this conversion a fair bit, or use that as the basis of a conversion. Okay. Next, that doesn't get us to where we need to go. We need to get to moles of electrons. Okay. To get moles of electrons, you take that Q, that charge. Okay. You divide that by Faraday's constant. 9.65 times 10 to the 4 coulombs per mole. Okay, that's the charge that 1 mole has, is Faraday's constant. This, memorize. It's on page 3. We're not going to do this calculation a lot, so few of you, and I don't memorize this number. I have to look it up. So the next slide, we're going to do a substitution like you might have seen in probably a grade 11 math class. We have Q is I times T. We've got Q in the second equation, and I'll put it all together, and that's the form you're going to need to memorize. So I'm going to do that substitution fairly quickly. So current is I times T. I'm going to take that, and I'm going to put it in place of Q. So instead of Q, I'm going to write current times time. So this is step 1. To get moles of electrons, you have to take the current times time multiplied by Faraday's constant. So your current's probably going to be in amps. If you have milliamps, milli would have the same meaning as milliliters. Okay? You have to divide by 1,000. Make sure your time is in seconds, and Faraday's will be coulombs per mole. And that's where our mole units end up coming from. All the other units cancel out. So I'm just going to update that plan from the first slide. It's current times time over Faraday's constant. That's what we need to get moles of electrons. Moles of electrons you can turn into moles of what you want. And moles of what you want you can turn to mass of what you want. It will always be pure. It will mostly be a solid. So next is an example that I'm going to do, and then after that, there's an example that you're going to work on. So this is what a test or quiz question might look like. So for example, what mass of zinc was electroplated on an iron nail if the power supply delivered a little over 9 amps for a little over 25 minutes? Forming metals is a fairly slow process. You're not going to see times of 10 seconds, 5 seconds. Ready? Okay. So I need to figure out what's my question and which way am I going through my flow chart or my plan. What mass of zinc? So this is our question. Mass, and it's not mass of question mark, it's mass of zinc. That's my starting point. So in this question, sorry, that's my ending point. I want to finish with the mass, so I am going through the sequence heading to the right. You can go either way, but this is my question. This is where I want to get to. So I need current and time, and then look up Faraday's constant to get started. So when I make that little list, I'm going to use current and time. That's going to give me moles of electrons. From moles of electrons, I can get moles to what I'm plating. What mass of zinc was electroplated onto an iron nail? Okay. We are plating zinc. This iron I threw in as a distractor. It doesn't matter what electrode it's going on or what metal it's going on top of. Okay. I just care about the zinc. Okay. And then I can get mass of zinc. Okay. The most common error done by students is forgetting this step. They get moles of electrons and think it's moles of the metal, and then they do the last step, and they're off by the whatever the stoic says. If there's 2 electrons, they're off by a doubling or a half. If there's 3 electrons, they're off by 3. So we'll get started. I times T over F will get us our moles of electrons. Current, that's in amps, so I don't have to do any conversion there. That means coulombs per second is the meaning of amps. Times our time. Now I'm going to stick in seconds right away to cue my brain. I need seconds, which I don't have. So I have to convert 25.2 minutes into seconds. Now there's a lot of ways to do this. I don't care how you do it. I'm going to use the factor label method. Okay. I want to get rid of minutes and I want to get seconds. The factor label, you set up a ratio that's equivalent top to bottom. So 1 minute is 60 seconds. So I need to multiply by 60 to get seconds. And in my work, I just punched that all into my calculator. I didn't write out what that meant. So I went a little over 9 times 25.2 times 60. That'll give me my seconds. I grabbed Faraday's constant from page 3 in my booklet. 9.65 times 10 to the 4 coulombs per mole. And that gave me 0.142 moles. And this is why I encourage you, remind yourself this is of electrons and not zinc, maybe by writing that in. So we started there, we got moles of electrons, we're on to moles of zinc. We do not need the whole reaction, we just need the half reaction that makes zinc. It's quite low in the table. So it's at minus 0.76 volts. And I'm going to copy this onto the board, though many of you would just look at your table. Zinc 2 plus plus 2 electrons will make that elemental zinc that got plated. We're always going to need 2 stoichiometric coefficients. The electrons is 1, and what we're plating, what we're making is the other, and that's the elemental zinc. So every 2 electrons makes 1 mole of elemental zinc. So we have 0.142 moles of electrons. Here's our stoic. I want to get rid of moles of electrons, and I want mole of zinc. And our half reaction says there is 1 zinc and 2 moles required. So my moles of electrons kind of cancel out. I've set this up to make sure, how do I know what goes on the top? It's what's required, what we want. What goes on the bottom? It's the type of moles we started with. Okay. So that's going to be multiplied by a half. And now I'm going to throw in zinc, cue my brain that that is the moles of zinc. Now we just need to get mass of zinc. So this is not a new skill. Okay. Mass, I'm going to keep putting in my subscripts, is molar mass times moles. Metals come in 1, so we go to our table, we get the atomic mass for 1 zinc. 65.41 grams per mole. Now you can do all of this continuously on your calculator, never rounding. Just leave moles of electrons, multiply by a half, multiply by molar mass. Grams will be our mass answer. I'm going to think of sig figs now that I've finished. All I've been doing is multiplying or dividing. So I want to keep the lowest sig figs, but realize these are perfect whole numbers, infinite sig figs. It's exactly 1 and exactly 2. So I'm going to keep 3 sig figs, including my current, my time, and Faraday's constant. They're all 3. 4.64 grams. So it took almost half an hour and we didn't even get 5 grams. It's slow. Electroplating isn't fast to demo. So that's cell stoic in one direction. A question is either this sequence or sort of bottom up. I'm going to give you a problem now, see if you can make a plan, execute the plan, and solve for either the current, the time, or the mass. Okay. So copper metal was electroplated onto nickel. The cell ran for 5.25 minutes at a little under 4 amps. What mass is this? So it's a similar question to what we just did. The question is mass again. You just have to think of, is it nickel we're making or is it copper we're making? And carry out the 3 steps. I'll summarize the answer for each step shortly. So this is the same sequence as the previous one. So your first step, moles of electrons, is I times T over F. If you do that properly, you get 0.01159 moles. You would have to have converted your time into seconds. Watch out with Faraday's constant. Ideally, you would use the built-in scientific notation in your calculator. You'd go 9.65, hit the second EE button, and it puts 1 E on your screen. That means times 10 to the power of, and then you can put in the power 4. When you use that format on a TI 83, 84 calculator, you don't need brackets. If you put it in the top version, you've got to bracket it so the times doesn't go to the numerator. You keep the times in the denominator. Okay. So that's a common error. If you need more help, see your teacher individually. So that's current times time. Next step is what are we plating? Copper metal was electroplated onto nickel. Okay, I don't care what it was plated onto, I just care it's copper. So the half reaction in your table is copper 2 plus 2 electrons makes elemental copper. Okay. The ions, we're not going to use those. We're just using the electron coefficient and the metal that is formed, the elemental metal. So it's the same ratio as the previous example. What we want goes on the top. So we want to get the elemental metal, which is 1, and what we know already is the electrons, which has a coefficient of 2. So I'm always writing 1 sig fig, 1 extra or the right amount, but please keep them all. We now know moles, and that is moles of copper. So you're going to end with mass of copper, molar mass times moles. The molar mass is just the atomic mass for 1. And I got 0.368 grams. Copper's atomic mass is 63.55 using my printed data table on the wall. Make sure you always use the Alberta data booklet for answering things. The one I have on the wall, or if you Google something, that's going to have potentially slightly different numbers. So for practice, both questions were in the same direction. For the sake of time, I'm going to have you work, but both were in this direction. Make sure in practicing, you do some that start with mass and go the other way. It is basically a guarantee you'll see one of these on your diploma, okay? And you're probably only going to see one on your unit test. So it's something you want to practice, a couple forwards, a couple backwards, and then probably stop and put your time somewhere else. It's just not going to be a big part. So you have 60 questions in your diploma, you know one more of them. We just don't know which direction the diploma writers are going to put.